is a giant rock that lights up our night and can even change colors. So what would we do without it? Would we all need night vision goggles? How would it affect the ocean tides, our seasons, or our sleep cycles? Or would the consequences be far more dramatic? Imagine a world without the moon. It's a thought that seems almost surreal, yet intriguing. But what would really happen if the moon disappeared? Let's dive into this fascinating hypothetical scenario and explore the consequences it would have on our planet Earth. And here's what would happen if we suddenly had no moon. As the closest celestial body to our planet, the moon exerts a gravitational pull that governs much of what happens here on Earth. Take the sea, for example. If you like surfing, you can thank the moon. To explore what will happen, let's go back a little to put it all into perspective. The moon has been hanging around us, literally, for 4.51 billion years. There are a few theories as to how the moon came into being. The main one is that it formed when a large object smashed into the young Earth. The early solar system was a chaotic place. A number of stellar bodies were created that didn't make it into a full planet. One of these bodies, as large as Mars, smashed into Earth, throwing huge chunks of our planet's crust into space. Gravity took over and tied these separate elements together. This explains why the moon is made of lighter particles than we find here on Earth. Billions of years later, and we're more than used to having the moon with us, it affects so much of our everyday life. The obvious one is tidal motion. The gravitational pull, or tidal force that the moon exerts on our planet, creates the tides. This force causes all of the water on the Earth's surface that's closest to the moon to bulge out to one side. A very short explanation is that it pushes in from the top of our planet and also the bottom while pushing out from the sides at the same time. The Earth also has an effect on the moon, which we'll get into in a minute. But it appears that the moon might not like our company as much as we might think. When the moon's gravitational pull tugs on our spinning Earth, the oceans respond, giving us high tides in some parts of the world and low tides elsewhere. And while the wind gives the waves their energy, tides define their shape. The moon's gravitational attraction also keeps us at a stable 23.5 degree tilt relative to the sun, giving us 4 seasons and a livable climate. But what if that livable climate were to suddenly become unlivable? With the moon gone, stabilizing effect on the Earth's rotation would go with it. It's slowly drifting away from us, even as we speak. The moon can seem small or large, depending on the lunar cycle. But in actuality, it's just over a quarter or 27% of the size of Earth. The diameter of the moon's orbit around us is nearly 477,213 miles, but this diameter is increasing by 1.5 inches every year, which of course means that it's moving away by a factor of 1.5 inches each year. To help explain why we have to analyze our relationship to the moon a bit more closely, both celestial bodies are tidally locked. We are synced up in such a way that we always see the same side of the moon. The hemisphere that we never see is often referred to as the dark side, but that's not quite right. As the moon orbits Earth, different parts are in sunlight or darkness at varying times. This change in illumination is the moon going through its various phases. The tidal forces not only affect our oceans, but the body of the Earth too. Because the Earth is more rigid in structure than water, the tides on more solid matter, like the Earth's crust, have a much smaller effect. While this is happening, the moon pulls back on the tidal bulge of the Earth, slowing its rotational speed, though just a fraction, a very small fraction. This means that 100 years from now, a day on Earth will be 2 milliseconds longer than it is right now. Blink and you'll miss it, literally. In addition, since the Earth is larger, the gravitational pull is stronger, causing the moon to speed up slowly. As time passes, its orbit will become bigger and bigger. This takes us back to that measurement of 1.5 inches. It may not seem like a lot, but over a period of time, this measurement becomes significant. Let's jump forward billions of years from now, where we see that the moon's orbit is so big that it does leave the pleasure of our company permanently. What happens to our oceans then? You've already guessed it. The tides will cease to be. That will make for very calm seas for any boat trips. That's if there are any humans left in, 50 billion years. Before that time, because of the tidal locking, slowing down the Earth's rotational speed, it's possible that the Earth will slow down enough to permanently face the moon. In turn, it may prevent the moon from moving away from us. Imagine the effect on our planet if we stop rotating. One half will always be in darkness, the other in light. That'll play havoc on our seasons and the natural life. While it sounds dramatic and the loss of tides would be a significant phenomenon, there are other more serious things to worry about occurring before then. In a tenth of that time, 5 billion years, our sun will likely consume both the moon and the Earth. Yep, our sun is going to have a galaxy-sized party, the likes of which our solar system has never seen, and everyone's invited. The sun is continually burning the hydrogen in its core into helium. Right now, it's approximately halfway through its life cycle. Towards the end, it will run out of hydrogen in its core. The sun will ultimately become a red giant. Its surface is predicted to reach Mars. That's when gravitational forces will take over. The Earth will be dragged into this new sun and disintegrated. The sun gets 10% brighter every billion years. So long before the planet is totally destroyed, the heat will have melted any ice and fried almost everything living. All of our oceans will have dried up too. So while the planet has a 5 billion year life cycle yet, everything living on it may only have a billion. To recap, the moon may move from the Earth, but the sun will have wiped out both long before the tides are halted. Let's steer away from that hot object and return to that sibling-like relationship of the moon and Earth. The fact that the moon has the same rotational period as the orbital period of both the Earth and the moon is no coincidence. Over billions of years, the tidal coupling of the two has led to the synchronization we know today. And yet, it's still evolving. The Earth is slowing its rotational period. Eventually, it will match that of the moon, and they will be exact. And as I mentioned before, the days on Earth will become longer as well, by 2 milliseconds every century. To have a significant impact, it will take many thousands of years. However, it's nice to think that both the Earth and the moon affect each other in many powerful and beneficial ways. It's almost like they're simply hanging out together like a couple of old intergalactic buddies. One of the most immediate effects of the moon's disappearance would be on our oceans. Without the moon's gravitational pull, tides as we know them would cease to exist. This would have profound implications for marine ecosystems and coastal communities around the world. But the impact doesn't stop there. The moon also helps stabilize Earth's axial tilt, which gives us our seasons. Without it, our planet's tilt would vary more widely over time, leading to extreme and unpredictable weather patterns. Furthermore, the moon's presence has played a crucial role in shaping life on Earth. Some scientists believe that without the stabilizing influence of the moon, life as we know it might not have evolved in the same way, if at all. In fact, the extinction of the dinosaurs millions of years ago may have been influenced by changes in the Earth's climate caused by variations in the moon's orbit. Without the moon to help protect us, Earth would also be more vulnerable to asteroid impacts. The moon acts as a shield, attracting and absorbing some of the space debris that would otherwise collide with our planet. But perhaps most importantly, the moon has inspired wonder, curiosity, and exploration throughout human history. From ancient civilizations to modern space missions, our fascination with the moon has driven scientific discovery and expanded our understanding of the universe. So, what would really happen if the moon disappeared? The truth is, we can only speculate. The moon's influence on Earth is so deeply ingrained in the fabric of our planet that its absence would undoubtedly have far-reaching and unpredictable consequences. As we ponder the mysteries of the universe, let's remember to appreciate the celestial wonders that grace our night sky. Whether the moon disappears or not, its presence serves as a reminder of the interconnectedness of all things in the cosmos. Thank you for joining us on this journey of imagination. Until next time, keep looking up.